Good morning, everyone. Oops, that came suddenly. So, who is here just because they were tired of queuing up for methodisch incorrect? Oh, no. So that's in the order of 10 at least. Yeah, nice. Okay, so let's see what we have here today. We have the lightning talk session on day 3. Could you please start my slides? So what we are gonna do is we'll have 20 talks, each 5 minutes, a very fast-paced session where everybody can pitch their own projects. And what I would like to explain to all the talkers today, to make things run smoothly, please sit in one of the front rows. Once your talk comes up, please quickly enter the stage and go before the microphone. Please stay close to the microphone because otherwise we can't hear you. And don't turn around because then we can't hear you as well. So you can see your slides down on the monitor. I can see my slides right now. I don't know what's wrong. But we'll work it out somehow. It's early in the morning, so bear with us here. Okay, you can see your slides. All you have to do is stay calm, deliver your talk. You can advance the slides using this clicker, which remains here on the lectern. So just pick it up, deliver your talk, drop it again, and then get applause. And well, I used to have a profit joke there, but that doesn't really work without slides. So what else is to say? For all the audience, for people in the audience, there they are, finally. Now I know what to say. So I had this, this, profit, yeah. So how to listen to lightning talks for all of you in the audience? Simply be excellent to each other and watch the timekeeper, which is this nifty device here. Alex will briefly explain what this is all about.
Yeah, I think you already know it. You have seen a lot of lightning talks. It just means if it's green, you are in the first 4 minutes of your talk. And in the last minute of your talk, someone mentioned, I said 30 yesterday. But okay, in the last 60 seconds, it will start to turn yellow like this. So now you still can relax. You have now about 45 seconds left. And if it goes down to 30 seconds, it becomes red and redder and more red. And in the last 5 seconds, it begins to flash. And now it's your part. 5, 4, 3, 2, 1. Better than yesterday. Thank you.
Okay, let's try it again, okay? Or were you satisfied?
Do you want to try it again?
I don't think we have time for that, so let's just continue. All right. So it always works better in real life. There are translations available. So English talks will be translated into German and French. German talks will be translated into English. Please see the wiki with the translations topic, and also see streaming.c3lingo.org for information on how to listen to the translated streams or simply watch the translated stream video. All right, let's begin. Let's do that. Let's start with the first talk. If someone needs water, it's behind the curtain. Thanks. So let's start with OpenAge.
Yes, hello. We are the development team of OpenAge, which is a free re-implementation of Age of Empires that probably many of you know. We require the original assets and do this mainly because of unlimited possibilities and writing awesome mods for that thing. We base that on mainly C++ and Python 3. For the user interface, we chose Qt. This year we have 3 main advancements, which is a web interface for our continuous integration system. The Neon configuration framework was my master's thesis, and we have an event-based game engine concept for the simulation calculation.
Okay, so let's start with the continuous integration system. Last year we held a whole talk about it. This year just a quick update. We have now actually included a web interface. It looks about like this. On the right you can see the output, the real-time terminal output, and on the left you can see the individual build steps with status and so on.
Neon is our configuration system for the game behavior, which is a plain text format, a bit like YAML or JSON, which contains key value pairs that can update values through inheritance, and where modifications are done through patches. And this is optimized for mod creation because patches can also patch patches, so that means you can modify everything in the game with a single system. So in this case, the generic unit is specialized to be a villager, and the super villager is an even more specialized villager, so that when you evaluate the health points, it's 35 for the super villager. The modifications are done through patches. In this example, when you discover the Loom technology, the villagers are stronger and then have 35 HP. But Neon can do much more because it allows patch transaction and history, and has many more data types, and allows mod combinations of overlays.
The new game engine concept is tickless and event-driven. It will only recalculate events or the future if necessary. It will store the whole history and future of the game, and the rendering is actually only doing a snapshot of the engine and then drawing it to the screen. There are different types of interpolations. You can have a continuous line, you can have discrete steps for arbitrary types. You have maps and queues that can be accessed over time. Then, for example, the unit description in C++ is you have a discrete curve of hit points and a continuous curve of a position. Then you insert a value at a specific time into this curve, and in the end you can access it at any value in between. And for example, you can predict that the arrow will hit the villager in roughly 5 seconds, then the hit points will go down to 0, so the villager is dead and stops building the building he's working on, and that's an event that's going to be triggered and issues a recalculation of this event. Like the building finished event will be predicted into the future, and if there's no villager working on it anymore, it will be dropped. And for example, an event will be the building construction finished, the building is getting damaged, or a unit starts together, and all the interaction in the game is described using these events and gets registered onto the buildings and onto the internal structures of the game. Like the building 42 triggers the event, its construction has finished at a certain time when it's finished. So our next steps for the project are the integration of those two systems to implement actual gameplay features that most of you have been missing for a few years now. We also need a cool pathfinder based on flow fields, and we also need a new renderer because the current one is really crappy, but we have a great guy already starting to work on that. So thank you for listening. You can meet us at the Stustenet assembly, and we hope to talk to some of our community contributors, that we have a lot of them. Thank you for your attention.
Thank you. Next up is Atari and Commodore fuck-ups.
Hi. I've got a problem that I've gonna have a 7-minute talks, which I have to squeeze into 5 minutes, so I have to take a few shortcuts over there. My motivation is purely just to entertain you. Back in the 70s, the TV was the only hardware that was capable of displaying something. So if you had something like a game console, you needed to have a modulator that modulates your video signal to the antenna signal, because there was no video in connector back then. At the time the Atari 2600 was created, only 5 companies built such a device. Nolan Bushney, as head of Atari, made an exclusive contract with each one of those, so he was the only one who could get such a device. Back when Atari was sold to Warner Communications, there was then one guy in bookkeeping and said, what do we need 5 suppliers for? One is enough. Fail. The video game crash of 1982. These 2 games are claimed to be responsible for it because they were so bad. I say these are responsible as well because they were so good. These games were programmed by the first third-party game development company, Activision, which was built by 4 guys from Atari who did the best games and asked for a different deal for their payment compared to what the musicians had together from their record companies. But they were declined very rudely. After that, Activision was founded and there was a lawsuit against third-party game development. Atari lost, so new companies spread and like mushrooms and built games that were awfully bad. So you could think of it, summarize the crash like this one. You send your dad out to get a good game and he comes back with 2 cheap ones. Fail. After the crash, there was a Japanese company that approached Atari. They had done a video game system released back in Japan that went very well, and they wanted to release it in the United States under the Atari brand. But Atari declined, saying something like, we could do better on our own. So the Japanese decided to sell the console themselves. That console, big fail. Let's switch to Commodore. The 264 series was originally developed as a successor to the VIC-20. And marketing needed a successor to the C64, so they took the only thing they had. And you don't sell a successor as an inferior system as a successor. This is what this fail looks like. Did they learn from it? No. They repeated the same mistake using the Amiga 600. This was originally developed as a low-end addition to the lineup. It's just basically a stripped-down version of the Amiga 500. And what makes this really bad is that the true successor to the Amiga 500, the Amiga 1200, was released only half a year later. So this is a way to piss off your community. And now let's get up to the most fun part. Commodore has developed a machine for business case use. You can think of it as one of the first laptops. For business use, because you had a modem built in back in the mid-80s. This is what the machine looks like, and this is what officially happened, and I'm going to tell you the unofficial story. The unofficial story is that the CEO responsible for the project got the first prototype presented on the golf course together with the CEO of Tandy, and the guy from Tandy just said, we did some market research, there's no such thing as a market for this kind of a machine. There's no way to sell this one. So, half a year later, Tandy sold that machine. Looks pretty much at the same target audience. So, another fail as well. So, my conclusion is, Atari and Commodore were killed by guys in suits who think that they know business, but don't know a shit about designing hardware and or software. Of course, this is not just my opinion, and my apologies to the translators for speaking so fast. Thank you.
Thank you. Now you still have some time left over. Never mind, we will just continue with the next talk, which is attribution generator. License notices for pictures from Wikimedia Commons and Wikipedia.
Hello. So there's actually a treasure trove of images on the internet that you can use. So when you write a blog post or when you want to publish something, there's probably some pretty picture that you can freely reuse, and it is available on Wikimedia Commons and on Wikipedia. But it's actually not that easy to probably reuse that, and I saw that in the talk that was just before that. Sometimes you see stuff like source internet, or this is a free image, I took it from Wikipedia. The Creative Commons license explicitly specify that you have to name the creator of the image and that you have to name the version and the name of the license. And then you are golden. Then you can take from this this great treasure trove of images to picture everything. So to make things easier for people who are not legal persons, we built a tool. And we want to simplify the reuse of images from Wikipedia and from Wikimedia Commons and give correct license and attribution. Because in this world where you give away stuff for free, there's actually a digital currency, and it's not Bitcoin, it is respect. And we want to make it easy to give the correct amount respect to these creators who give away stuff for free. We have an English version and a German version, and we released that last year, and quite a few people use this very simple web-based tool to create a correct attribution line for images that they find online. It works pretty easy. You have a URL attribution -generator.org. There's a typo in here. Or you can use the amazing German word Lizenzhinweisgenerator. You just paste in the URL of the Wikipedia page where you found the image, or you paste in the URL of the Wikimedia Commons page where you found the image, and then you go through a few questions and it asks you, do you want to use it online, or do you want to print it in a book, or do you want to use it together with other works, or do you want to crop and modify the image? And then after that, you will get an attribution line in HTML for copy and pasting, what have you. It makes things very easy for those of us who don't speak legalese. Just use these. Just use this tool. It is a lifesaver, and it will keep you out of all the nasty things like cease and desist letters, Abmahnung, and it makes the world a better place because you will give credit where credit is due. We would like you to get involved. We think it is a very simple tool with a very simple use case, but maybe we can improve it. If you have ideas how to improve it, just tell us. Best thing would be to write me an email. And also, if you speak an interesting language that is not German, English, Spanish, or Portuguese, contact us, and we would like to translate the interface into your interesting language. That's it. That's all I have. Thank you.
Thank you. Next up is database data layouts.
Okay, hi, I'm Stefan and I'm a database researcher. And I like to say that designing databases is as hard or as exciting as constructing rockets. But I don't know how to construct rockets except for Lego rockets. But let me introduce you to database design. And there are many design decisions, and I want to talk about a small design decision, and that is the data layout, which means how you map your data to the memory. And especially this talk is about data layouts for relational databases. And here's an example of a table which you store on relational databases, and it consists of tuples, so you have different rows, and all these tuples have attributes, for example, first name, last name, and country for persons. And as you can see here, table data is two-dimensional, so you have rows and attributes, and the issue is that memory in computers is usually linear, so one-dimensional. And then you have to decide how to map two-dimensional data to one-dimensional address space. And basically you have two design decisions, so this is simplified. And what you can do is you can store your data in a row store, which means you store data of a single tuple together, which is shown on the left side. And the other possibility is that you choose a columnar store, where you store all the data of a single attribute together. And then you may ask how to reconstruct tuples, but this is quite easy. For example, to get the third last name, you have to know the starting point of the vector for last names, and then you jump to offset 3 and find winter as the third last name. And then you might ask, why does it matter? And the answer is, it's not important how much data you access, or it is important, but what is also important is the access pattern. So if you do a sequential scan in memory, it's way faster than random accesses. And to show you this, I will present you 2 micro benchmarks. So one is an insert, so we want to add data to our database, and the other is a filter operation. So think about an SQL statement where you do a select filter from our persons table and filter by first name. The interesting question is why it's important to do micro benchmarks. So think about design decisions, and maybe you have a good idea, and it turns out to do experiments and show that the idea is good is way harder than the idea itself. And then when you have the experiments, it's way harder to productize it and make this experiment robust. And so how does it look like for insert? So for a row store, we can copy all our data in one place, and for the column store, we have to append the data to the different attribute vectors, so jump to different address locations. And as a result, so here a simplified measurement, we can see that the throughput of memory is way higher for row stores than for column store, especially when you have a large number of columns. So the small effect that column store is better here than the row store for a small number of columns. The reason for this is that we use memcopy, and memcopy has a small overhead when copying small data chunks, so then it's better to do a variable assignment, but for large data copies, it turns out it's quite good. So this was a row operation, so row database is better. And now look at the other way around, so operation where we have access pattern with benefits or access attributes. And you can see this here. And this time for row store, we have to jump in memory. So if you want to access all first names for the row store, we have to access the first tuple, then jump to the next tuple. And there we have these memory jumps. And for the column store, we can basically just do and scan. We did again the benchmark with different selectivities, and this time it turns out that really the column store has a higher memory bandwidth. You can see again that also the number of columns has an important role. You can all explain these with how caches and cache hierarchies work in modern CPUs. And basically what I want to show here is this is just comparing your data, and normally in the database you have to store intermediate results, and then you don't not only do the comparison, but also have to write the position list, so the intermediate result, and then it turns out to be a bit different. Okay, so thanks. I hope you're excited and want to develop your database by your own, so have fun with it.
Thank you. Next up is Remarkable. Yes, Remarkable.
Hi, I'm Axel, and I decoded the binary format. So I'm talking today about the Remarkable tablet. As you see by my beautiful drawing on it, that's a tablet with e-ink display where you can draw on. And without advertising it, I was actually looking for the parts that are interesting, which are the software parts, because that's the part that I understand. So the thing is, the Remarkable runs on our ARM and Linux. We have full root access to it, and that makes it very interesting to tamper with it and to explore it. Short disclaimer, blah, 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 you can see it in the screen. What does it do? If you draw on a tablet, it basically records your complete thoughts, and that's something that you might want to control. So the thing is, you can export the data that you have on it, and you can import data there, for example, by PDF and PNG, but internally it's stored in a binary format. And we really want to understand that, because that's what we control at the end. So unfortunately, that's not well implemented yet, and we'll maybe update it, but anyway, we want to know what's going on there. Also, you want to have more features when you draw on something. So for example, you want to have text recognition, you want to see the animations while you draw it, you want to have more brushes, whatever. So that's a short motivation for that, to understand how something stores it. So why docx, for example, is crap. But actually it's just fun to see what a binary format looks like. And I never did this before. So the idea was just decode it. So in the Remarkable there's some file for each notebook. So this is a page to write on it, and that's called lines file. And when you just open an empty file, it looks like this. So there's not much in there. It's just a header and then some zeros. That's cool, but now we want to understand how drawings get added into these files. So what I did is I took a pen and took the did the smallest dot that I can do on the device. It really looks like 1 pixel. And when I did this, the file changed to this. So we see already there's a block of data, something in a hex editor that comes in there, and there seems to be a number 1, which could be the number of times I hit the surface. So what can you do next? Make it a little bit more complex. So just try to add 1 more dot to a page. If we do that again, we see there's another blob coming in there, and the 1 changed to 2. So what did we find out already? There's a fixed header, cool. There seems to be a counter how often I touch the surface, cool. And that's very important if you want to continue decoding it, there seems to be no compression involved, because otherwise the first part would have changed if I put in the second part. So now let's do this a little bit more systematic. But I wrote a couple of lines of C++ code and built up a little matrix. For what I did is I seek to a certain position in the file, and when I open this, I did this tables here, and every column is a different interpretation of the next byte or the next bytes. And I added offsets to the line, so just in case I don't know what something is, I just seeked on and on and on. How does this look in reality? So let's go to after the header and have a look in the file, so we can see interpretations of what could be the next data type. 4 seems reasonable, right? The float doesn't make sense. That means the next 3 bytes are crap. Makes sense because there's only crap in there. Next one could be a 1, okay, the other ones are zeros, makes sense. And go on and on and on. The last one could be interesting, so even the ints are not reasonable here, but the float looks interesting, could be a pixel position, because it's inside the resolution of the device. If we continue like that, what you will get is something like this. So I learned int, and then float, float. Cool. So if we do this for 1 point, then we can start from the inner to the outer and try to understand what we got there. So just group this a little bit. I know that the device has pages. Inside these pages it has layers because it's visible in the GUI. Inside the layers you can have lines, and lines are grouped to dots because I can draw lines, right? So when I just start then to modify the dots that I put on the device, you can just systematically explore, and what you find out then is that actually the 3 floats are coordinates. The pressure changes if I put more or less the pressure on that. We have a rotation of the pen, and all of that is then grouped again into a line. A line only has 1 brush, and putting this on and then adding new pages, you just see what changes in the file. And with that you can get meaning from the pure data types to what's actually in there. Of course, the next point has to be to document all the magic numbers and the numerators in there, so I did that. And the interesting aspect that's also in there is actually the ranges of the data you can get in there. So for example, the device records the angle that you have to the normal of the surface and in both directions, which is interesting because it doesn't support brushes which are not symmetric, actually point symmetric. But it could. So that's interesting, that's what we learned. So obviously last step is implement the new renderer. That's the original, and I just played with colors, and all of this is now open source, and you can find it on Lines Are Beautiful on GitHub. Thanks.
Thank you. Next up is weapons patents.
Hello, my name is Felix. I'm working in intellectual property department, and privately I came across the subject of weapons patents. I found out that there's very few poor awareness of the risks of weapons patents, and so I want to highlight some risks associated with weapons patents. I will relate weapons patents to crime. This is what constitutes one risk associated with weapon patents. And so let's go. I found some correlations. First, I want to correlate the time when weapons patents got even more dangerous in the end of the last century. Then they went online. Beforehand, they were paperwork, difficult to access, or behind paywalls. But in October 1998, the European Patent Office decided to publish them online without any restriction. The American Patent Office followed 6 months later, in April 1999. If you correlate this with a German terrorist organization, Red Army faction, which caused much trouble and who killed many people in the last century, you found that this organization could not take profit from weapons patents because it was too late. But if you talk about Al-Qaeda, you will find that this organization came to public awareness in 1993 with the first attack on the World Trade Center. At that time, there was no possible means to access knowledge about weapons patents by the means of the internet. But more than 2 years after all these patents went online, they did a second attempt, which was successful, as we know. This is only correlation, no proof of whatsoever. Here I show one example of a weapons patent, particularly of this patent. First of all, it's published by the US Army. It is told that this is recommended for unconventional warfare activities, which means guerrilla fight and terrorism. And if you have a look on this document, it's quite descriptive. It gives a clear indication how to build such a weapon, which material, which quantities, and all this. I would have liked to find any evidence that the crimes of the destruction of the World Trade Center is related to weapons patents. I didn't find anything like this. There's no evidence. But what I found when I studied the official paperwork is that the NIST, the National Institute for Standard and Technology, which investigated in these crimes, that did not even think about the possibility that terrorists, that suicide attackers, did an attack from the inside. This is what I marked in red, is that they assumed that professional people went into the buildings, may have gone into the buildings, planted some explosives, left the building, and went away before the final attacks took place. The possibility of suicide attackers inside the buildings was not taken into account. My conclusion, I think it's a good idea to change the official storytelling, which tells terrorism is a very, very big harmful to mankind, and we should sacrifice sacrifice our yes. Thanks a lot.
Thank you. Thank you. Next up, a proposal heating method for coffee.
Hi, and welcome to a not-so-serious talk about a novel coffee heating method, which is an application for in situ use of resources at the office with responsible use of modern manufacturing technologies. So why do we want to heat coffee? Well, I work in science, I code a lot, and I tend to forget about my coffee. Coffee usually tends to get cold with time, and as probably everyone knows, cold coffee isn't very good coffee. So we need a solution which utilizes the resources we have at the office. And yeah, that's first. For that we need some sources of thermal energy. First I looked into humans because, well, there are a lot of humans at the office. They produce, as you can see in the chart, around 100 watts at room temperature when seated. But that's energy that is at 36 degrees Celsius. It's really hard to harvest because you don't want to put on a bodysuit or whatever to harvest the energy. So another one would be electricity, but hey, come on, that's cheating because electricity is everywhere and I would need an additional device. So the night before I saw Star Wars and then I remembered one quote. I think it was like this: the target area is only 7 centimeters wide, it's small thermal exhaust port right below the keyboard. The shaft leads directly to the main processor. Hey, my computer has that too. Okay, now we found a source for thermal energy, and how do we harvest that? Yeah, as you can see in the picture, that's a double-shelled mug, which is hollow on the inside, and hot air gets blown from below around the coffee and vented on the upper side. And now we need to build this. So as I said, I work in research. We work with metal 3D printing, so I got it printed in aluminum. You need to do some reworks on that. So mug on the mill was a first for me. And now the very important part, we need to verify this solution. Okay, I set up an Arduino with 3 temperature sensors, which measures the temperature of my mug, of reference mug, and the ambient temperature. This data is sent to a computer in intervals of 1 second because thermal processes are really slow, and that should be sufficient. A script visualizes that in real time and also stores the data in an HDF5 container because, scientific data, and I can process it further afterwards. As I said, I needed a similar shaped conventional mug for that, for reference, and then filled both mugs with the exact same amount of coffee using highly scientific methods. And because we need this to be realistic, we also added milk. 24 milliliters of this, to be precise. Highly scientific methods look like that. And the milk was added, just with a syringe. And then I wired it up, set it up at the computer, and started the testing. So to generate sufficient thermal energy, I ramped up some simulations and got some results. Before I show you the charts, I know now that coffee with 60 degrees Celsius is too hot for me, definitely. You burn your tongue. Between 50 and 60 degrees Celsius is super nice warm coffee, I like that one. Down to 40 is still acceptable because, it's still drinkable, but 33 degrees Celsius definitely too cold. And also, drinking coffee with a wire stuck in the mug is really, really weird. Because it's everywhere and in your way, and you don't want to do that. And it's especially weird if that mug is made from warm aluminum. So that is the chart. You can see the red line is my heated mug, which performed, as expected. It only sank to a higher temperature than room temperature, but that wasn't enough because you can see the regular mug, which is in green, that after 40 minutes the coffee in the regular mug started to get colder than in my heated mug. That's not really good. So my conclusion to that, the proposed device did not really show the expected performance because the aluminum outer shell acts as a heat sink, transferring the heat from the coffee to the outside. So I need a new device with less thermal conductivity and while maintaining inner shell.
Thank you. Next up is Interledger.
All right. Hello, my name is Evan Schwartz, and I'm going to be talking to you about an open payment protocol called Interledger. So today, payments are broken. This is roughly what the payment space looks like. It's super fragmented, and there's tons of small regional networks that are all separate from one another. Each of these works well within themselves, like Sofort in Germany, Ideal in the Netherlands, Venmo in the US. Each one of them works well, but it's impossible to pay from one to the other. As a result, you have just a few really major global brands that basically dominate global payments. If you look at Visa's slogan, everywhere you want to be, they're not saying we're the best, we're the cheapest, we're the fastest. They're saying we're the biggest. Today, payments is all about network effects and reach. As a result, no one can really compete. If I started a new payment network today and said, oh, come use my network, your first question would be, who can I pay with it? It's all about network effects. The real fundamental problem is that all of the payment networks are disconnected. Whether they're banks, blockchains, mobile money networks, etc., all of them are disconnected. And in many ways, this resembles what information networks looked like before the internet. So what we need is internetworking for payment networks. We need a system that makes it so you can pay from any network to any other network. So then it wouldn't matter if you and I are on the same payment network. This is what Interledger is. Interledger is a protocol for relaying packets of money across many different payment networks, just like the Internet Protocol does. Interledger provides three main things, which I'm just going to go through very briefly here. If you're interested in more details, come to the session later. So first, there's a ledger-agnostic address. So this is a way to say where you would like to be paid, no matter what payment network you're on. The second is an IP-inspired packet format that's super, super simple and just communicates to the intermediaries basically the details of the payment. The third thing is multi-hop security, because dropped packets when you're talking about money are a little bit more serious than dropped packets when you're talking about IP packets. As I said, more details if you come to the session later. Some key facts about the Interledger project. It's an open project. We work on it mostly under the aegis of a W3C community group. And there's 275 members that have a lot of different backgrounds, ranging from banks, central banks, payment companies, blockchain companies, etc., because Interledger is meant to be a super generic payment method that can be used for lots of different applications. So to talk a little bit about implications of this is a graph of what internetworking did for data. Basically, costs plummet and volume explodes. Because as you add internetworking, you add interoperability, it makes it not matter which network you're on, increases competition, and the costs come down. As the costs come down, they get so low that you can suddenly start sending information for many more use cases than were possible before. Imagine doing some of the things we do over the internet over traditional mail. Just impossible. So this is basically what we expect to happen with payments with interoperability. So to leave you with three kind of pieces of food for thought, I'll pose three questions to you. First, what could you build with free and instant global payments? Imagine that you could pay or get paid by anyone in the world in any currency, in any amount, small or big. That's question number one. Number two, a lot of people have talked about the problem with the internet's business model today. Today it's all based on advertising. There's only a few companies like Spotify and such that can actually convince people to take out their credit card and enter those details for security reasons, user experience, etc. Imagine if your browser could just pay for the services that you use in tiny little amounts, and you could just control it with kind of a dashboard with sliders. That's the kind of thing that this could enable. Third, as I mentioned briefly, Interledger is heavily inspired by the internet itself. And there's an interesting issues that come up around what lessons should we draw from the internet? What should we copy and what mistakes should we avoid? Very interested to hear people's perspectives on that. So, session today at 6:30 p.m. in seminar room 1415. If you're interested, you can also find us online, interledger.org, and on Twitter. Thanks.
Thank you. Next up, Balkon.
Hi all, good morning. So I want to present our small conference that we are organizing in Serbia, in Novi Sad. And by the way, I'm Jelena. So what is Balkan? Balkan is meant to be a small hacker conference in southeast of Europe. We try to build there a community because a lot of people and students from that part of the region doesn't have so much money to travel there on such a conference as a CCC or some other places. So we started to organize first Balkan 2013, and next year will be our 6th conference. So I want you all to invite to join us for the next Balkan. The dates for the next Balkan is 14, 15, 16 September. It's in Novi Sad in Serbia, so it's, let's say, 1 hour drive from Belgrade. And you have here all the important deadlines. But why Novi Sad and why Serbia? Because we are from Novi Sad, we decided to make a conference there, but we are not living in Serbia anymore, but we wanted to give community there some feeling of the hacker conferences from the Europe. So you can see the pictures of Novi Sad. What can we promise to you? We can promise to you very good food, cheap, very good drinks, a lot of parties, and a lot of fun. We also have great speakers that are coming every year. I don't want to tell now the names, but on our website you can see all the lists of the speakers that was last 5 years with us, and they are coming back because it's not a big conference. Last year we have around 450 people. It's familiar feeling there. You have an opportunity to speak with everybody. So I think that's important, and I want to all invite you to help us to build a community in Serbia, because there is not so much hacker community. We have 2 hackerspaces, one in Novi Sad, small one, it's 2 years old, let's say now, and one in Belgrade, more than 5 or 6 years, I'm not so sure. So we are trying to build a community there, but we need people from abroad to show the people in Serbia how it looks like. So that's the reason why we are organizing the conference. And we also have on the Balkan a small hacker area, so we also have assemblies, and we also want to invite all the assemblies to come to join us to have fun these 3 days. So if you have any questions how to reach the Serbia, because it's maybe for somebody it's not so easy, there is a cheap flights to Belgrade. It's 1 hour drive with a bus from the Belgrade airport to Novi Sad. Or if you have any other question related to accommodation, organizing conference, feel free to contact us, write us email. We'll want to see you all in Serbia, in Novi Sad next year. Thank you.
Thank you. Next up is Capricorn.
Hi. So earlier this year, ransomware spread out pretty much all over the globe, according to the news. Luckily, myself, I wasn't infected, but I made a program which tries to detect what changes are made in your file system. And today I'll tell you something about that, and I'll end with a call for activity. So first off, short table of contents of what I'm going to present. First, a bit about myself, who am I? Then what is Capricorn? How does it work? And how can you join in, which is the initial goal of my presentation. So, who am I? My name is Max Kersten. I go under the nickname of Libra, and I'm in the 3rd year IT security bachelor in the Netherlands. I'm interested in reverse engineering and analyzing malware. I did Android banking malware for my internship. And I plan on writing my final thesis about desktop malware, because I'm also fairly interested in that. Which brings me to my program, Capricorn. It's an anti-ransomware command line interface application. I didn't feel the need to build a graphical user interface. Though it's still possible. It's built modular, so it can be expanded rather easily. Open source. You can find at the end of the presentation a link to the GitHub repository. And it's written in Java. It supports both Linux distributions and Microsoft Windows. It uses local honeypots, a bit more about that later on. And one other rule I used is to not require administrative or root privileges. So how does it work? I deploy honeypot folders with files in it on the system in multiple locations. All of the user home folders are used. So that would be your desktop folder, your documents, your videos, any of these. And the root of your file system itself is also used. So if you're using Windows, it's probably the C drive. And if you're using Linux, that's just the slash on your device. So then I fill the honeypots with files with a random extension. I use my own hard drive as a super reliable source of what extensions are used most. And I got roughly 700 extensions there. And then I fill the files with words based on the English language. I used some sites and I found out what the allegedly most used words in the English language are to avoid detection, since other programs which use similar techniques as I do, they often have words in them like, this is a test file of do not remove anti-ransomware. So ransomware could be able theoretically to check that and then not encrypt these files. Since I want them to be encrypted first, that is my goal. So what do I do if there's a change in these files? I simply shut down the machine. Usually crypto software doesn't have a persistence mechanism because files are encrypted anyway, so they want you to pay. So the current state of ransomware, so it's first executed obviously, scans the file system, it targets a set of file extensions, so PDF, docx, I don't know, whatever they want. And then it starts encrypting downwards from the location it started usually. But it could be user folder, the root of the hard drive, and then eventually you've got the message, well, please pay us or you're never going to see your files again. So far this works, at least for the criminals, sadly, but the program also prevents it. I tested it with quite some versions. Also the world famous WannaCry would have been stopped, at least in my test machines. So what I might foresee in possible changes in ransomware is that they also include the header of the file. So that's been something I've been working on lately, to have the correct header for the correct file extension, because otherwise it could be that the plain ASCII text in the file is seen as a honeypot and is skipped. And if all the honeypot files are skipped, the program doesn't work anymore. So that brings me to my last slide, is how do I participate? After the lightning talks are over, you can contact me outside in the hallway, you can email me, or on GitHub. Thank you.
Okay, then let's continue with the next talk. And the last talk before the break, RIOT, the friendly operating system for the IoT.
Hello, my name is Martin Lenders. I'm a researcher at Freie Universität Berlin and also a main contributor to the RIOT operating system. So most of you might want to know, why do we need an operating system for the Internet of Things at all, and why RIOT? So if you look at the Internet of Things today, we see that most manufacturers just use their own solutions, mostly proprietary, sometimes standardized, but almost always over some central cloud architecture, and also using some proprietary software, and basically no one knows what they're doing. And our vision for the IoT is that basically everything is built around free software and free and standardized protocols. I put some RIOT logos in the slides there, but you also can use other open source operating systems, of course. So that we basically, if we want to connect our heater with our light switch, but why do we need a dedicated IoT OS anyway? Why not just use Linux? Well, if you look at the devices Linux usually supports, we see that there is a big difference between the devices RIOT supports and the devices, for example, Linux supports. And so our motto is basically, if your device cannot run Linux, use RIOT. But what does RIOT bring to me? Well, firstly, we are LGPL licensed software, so we are basically free software. We also support a variety of well-known and well-tested tools for our development process, so we don't require you to install some Eclipse environment or use some self-written IDE to develop for RIOT. And we also support a variety of platforms like the maker's favorites Arduino, Nucleo, ST Nucleo, or the Adafruit Feather, but also educational platforms like the Calliope Mini and its British counterpart, the BBC Microbit. And we also, you might have seen it on Hackaday, that one of our contributors hacked the IKEA light bulb Tradfree for RIOT, so you can run RIOT on that now. And here, for the ones who are a little bit more technically interested, RIOT basically has a real-time capable kernel architecture, a highly configurable modular design from the ground up. It has a partly POSIX-compliant API, a fully featured IPv6 network stack, and also JavaScript support via the Samsung JavaScript interpreter, and also some other third-party software which you can also include via a BSD port like package management. So if I could spark your interest, you can look at our website, riotos.org, look a little bit through our API documentation at api.riot-os.org, and look at our GitHub tutorials if you want to test yourself out in the environment. Also, we have several mailing lists. Our most active one is the Devil mailing lists, where we discuss most of our topics, but we also answer questions at the users mailing list, and if you find any vulnerabilities in RIOT, you can confide with us at the security mailing list, security@riotos.org. Thank you.
Thank you. Okay, so now we're going to have a short break of 15 minutes. We'll see you all back at 12:45. Please give a big hand for all the talkers. Okay, the break is about to be over, so please switch to the slides again. And then we can start with open source do-it-yourself laptop.
Okay. Hello, I'm Lukas Hartmann, and this is a quick intro to Reform, my open source do-it-yourself laptop. Why? A computer should be a simple tool. The users should have all the power over it. You should be able to completely understand and repair it, and there shouldn't be any corporate or government intrusion that you don't want. There are some similar projects like the Novena, that's also based around IMX6. There's the Pyra, the Neo 900 phone. So this is my contribution to the overall open source hardware movement. The status, there are two prototypes. One is based around a development board and is quite a bulky box. This is done and works. The second prototype is currently in the works. I have it here in this suitcase, so I can show it later after the talk. It's based around a custom board and it's much thinner. Here are some first sketches how it all started by industrial designer Anna Dantas. We iterated on a lot of different styles and ideas how it could look like, and for the first version settled on a very simple blocky design. This is the very, very first version made from laser cut acrylic, 3D printed keycaps just to get a feeling of the proportions and so on. We then started to print our own keycaps in the Formlabs Form 2 resin printer. This is how they look freshly baked. This is the completed first prototype insides. You can see there's a lot of cables and components floating, so that's why it's so big. And me using Debian Linux on it, and it can show its own photo. Here are some more renders showing how it could also look like. The general specs, it is based around the NXP IMX6 SoC. It has 4 ARM Cortex A9 cores at 1 GHz, 4 GB of DDR3 RAM, which is unusual for an ARM system. It has a Vivante GPU and a safe lithium iron phosphate battery. And it's completely open. There are no binary blobs in the system. The GPU is completely open source, has completely open source drivers. It's currently based on the TinyRex SOM, but we'll move to the OpenRex SOM, so it can also be replicated. Yeah, it has a bunch of I/O for USB, PCI Express, SATA, Gigabit Ethernet, LVDS, and HDMI at the same time, and the SGTL5000 sound chip, and there's a few GPIOs and SPI I2C for your own experiments. All the files are open as step files. You can print your own enclosures and parts. The board was designed by me in KiCad, which is also open source. All the components are easy to source, and the input devices, the keyboard and the trackball, are just USB devices. And this is how it looks like in KiCad. This is my first 4-layer board. Here's a render, and this is how it looks like in real life. I was able to, with a lot of patches, to bring this board up and runs some emulators on it. Here you see it almost fully populated. The USB hub didn't really work. And I was able to test a lot of software in the last weeks. Debian Linux runs fine with the mainline kernel. Firefox, Blender, Emacs, IOQuake 3, MPlayer, LibreOffice, all of these work quite well. And I'm now working on the board revision number 2, which fixes a bunch of problems that the current board has, and the case revision number 2. And we'll start taking pre-orders soon for a complete DIY kit. Here is just a preview of the thinner enclosure. Thank you. You can contact me here, mntmn.com/reform, or talk to me here later. I have all the parts with me, so thanks.
Thank you. Next up is Shit Might Hit the Fan driven code.
Good morning everyone. I want to talk about shit might hit the fan driven code because this year I had the feeling, and I think I'm not the only one, that shit is very close to the fan. Or as another talk here framed it very, very nicely, we might not go the direct route to utopia. There might be some detour, and so I was writing some code, mainly Android apps, to deal with my fears and to basically make some digital umbrella. Because main thing is I don't trust the elected leaders we have currently, and I just want to have a backup. So we will go up the pyramid of needs, and I think it's not Wi-Fi at the bottom, it's actually food and shelter. So I was checking all this, like, how to make fire and stuff. And there were some apps already on the Android App Store, but none on F-Droid, which is really a problem for me. And I didn't like all these apps, so I was writing one. It's based on the US Army field manual, but completely demilitarized. So if they speak about soldiers, it's humans and everything else. It's based on a wiki. This is basically the content, and I added some, for example, power, because often people ask, yeah, there's no power when shit was hitting the fan, but there are solutions to that. You find that in that section, basically. So there are ways around it, how to generate your power. That's added content. So please, that's one reason why I'm speaking here. Also add your content. It's a GitHub wiki, and that gets compiled into the app. And it's also not, it's called offline, survival manual to help overcome situations without internet offline. That doesn't mean like offline. It works offline, so the content is compiled into the app. The next thing I want to speak about is IPFS Droid, because I think like that's one step ahead of the pyramid now. Now we survive, we have shelter, we have food, we have everything. Now we really want digital content. And one really nice way to get digital content is IPFS content addressable, and that's basically the Android app to access that. It can resolve via the Go IPFS node that's compiled into the app, or also via the gateway to not have such a big binary blob in there. So please look up IPFS and IPFS Droid. Another option might be Swarm from, yeah. Next thing I want to talk about is Wallet. That's like this cryptocurrency thing is not really well received here, but it's not all about money. There are other things you can do with that. And also like banks might explode after shit hit the fan. And you still may want some means to exchange stuff and don't go back to raw barter. And also none of the apps for Ethereum were suitable for me before, so I was starting the Wallet project. I started that as an organization. There's also a lot of Kotlin code. If you don't like JavaScript and you like static typing languages, in the Ethereum and IPFS space often JavaScript is dominant, but most of that stuff is written in Kotlin. So now we are at the top of the pyramid, basically. We have some time, all needs are solved. One game what you can nicely play is Go, like the game of Go was also really interesting. AlphaGo now with the AI. You can also find that at the Hive, an installation which plays the AlphaGo games with that app basically as a continuous playing. All the apps, you find them on Google Play for your convenience, but you can also compile them yourself, and in the middle from the convenience also always all the apps are available on F-Droid, your choice. The next thing I want to talk about is not an Android app. That's I saw that the Canary Watch stopped basically because it's too much work currently to monitor canaries, and I really like Ethereum, not for the money like stuff, but you can do like as a smart contract. Please look up ERC 801. That's an ERC to make canaries. So it should solve all these problems that are outlined in this blog post. Yeah. So follow up, you find all that stuff on my contact, PGP key and stuff on ligi.de. Contact me also like at this conference here, just speak to me. I might look scary, but usually I'm quite friendly. Have a nice day and a great conference. Thanks for listening.
Thank you. 5 lightning talks in one. Very nice. So let's continue with Technological Sovereignty, Volume 2.
Hello. So I am Maxigas, and I will actually talk about a book, not software. And of course it has digital versions as well, but we printed out a bunch of them and they are available in the Anarchist Assembly in Hall 2 next to Komona. And well, this is a book written, actually I should show you this, written by people who live in the eco-industrial post-capitalist colony in Catalonia that is called Calafou. It's a kind of housing cooperative, and productive cooperative complex that we are buying from the owner over 10 years. And technological sovereignty itself started with this idea from Margarita Padilla. And he was saying that there are consumption cooperatives that buy their food from local farmers together, and why not people do the same with technology? So we found Via Campesina peasant movement, that is an international political movement of peasants. And they had this nice definition of food sovereignty, and what we did was to adopt this idea to technology. So I will read this quotation from Via Campesina and try to imagine what happens if you replace food with sovereignty. So food sovereignty is the right of people to healthy and culturally appropriate food produced through ecologically sound and sustainable methods, and the right to define their own food and agriculture systems. It puts those who produce, distribute, and consume food at the heart of food systems and policies, rather than the demands of the market and corporations. So for us to adopt this idea to technology was a way to go beyond the limitations of free software, because free software was a very inspiring and powerful movement, at least in the 1990s, and by now it has become part and parcel of capitalism. So we were looking for a more holistic approach to alternative technological trajectories. The first, 3 years ago we published the first volume, and this is the second one that came out now. It was supported by the Ritmo Foundation from France, and it was translated to Italian by people from Hack Labo in Bologna. We collaborated with a lot of other groups, for example with Coati, who are a translation collective. So the first volume 3 years ago we put out in French, Spanish, Catalan, and now in the Anarchist Assembly you can actually find the new Italian translation of it. The second volume that we publish now will come out in, it's already out in English and Spanish and available in the village. There is already a digital version in French, and Catalan and Italian will come up. So one of the reasons we came here is not just to distribute the book, but also to ask people if they want to help with German translations or translations to any other random language that you desire and speak. We published the book also, there is an original version, so if you want you can get the digital book, and you can have the original French articles in French, and if somebody wrote in Spanish you can have the Spanish version. So altogether we are releasing in 6 different formats, in print, in HTML, in PDF, in Markdown, in Mobi, and in something else, EPUB. So it's basically 6 times 6 books that we made from the same material, and they are all available in a JIT repository. So we use, actually I will show you this one. So we have this toolchain based on the JIT book library mainly that we use to translate Markdown. That makes it very easy for translators and collaborators to work on the book. Just to give you a taste of what is in the book, the first volume looked like this, and how is it? Yeah. Sorry. So, okay, in the second book you find
5, 4, 3,
you find a lot of different topics, from leaking platforms to software. Thank you.
Thank you. All right, next up is formal verification for the win.
Hello, I'm WildHacks, and my talk is formal verification for the win. So it's well known that the number of bugs generally increases with lines of code, and we have a whole slew of code around us. So embedded devices are what we have in our smartphones or cars or elevators or railways or wherever, and they have code in them, and there is a lot of them. Even in 2004, cars had 70 computers in them in different networks. By now you can be sure that you drive a car that does not work mechanically, as in when you press on the gas, there is a command sent to a computer which operates the engine. It's not mechanical, and there is code in between. They actually boast about it. There is stuff from the mundane like HDDs to the internet backbone, which is critical. And there are actually standards around it. The column on the right is how often a bug is supposed to happen at maximum. And it's really hard to test that a bug happens only once every 12,000 years when you're a manufacturer. But when you release something in the wild with millions of devices, consumers find bugs. Another issue with the testing process is you test for known issues, and you generally don't know issues which are interesting. So there are cases like a Toyota one where the car did not stop when you press the pedal, just did not because they messed up concurrency, and people did die, almost 100 confirmed deaths and a lot of injuries, and they tried their best to keep it out of the court, so they settled a whole lot of cases. Also look it up with Michael Barr and Philip Koopman. There is sort of interesting slides with expert witnesses, and they audited the code. Another legendary case is CEREC25. Basically, it's an X-ray machine which sometimes worked in kill cancer mode when it should have worked in scan mode, and also killed people, and also because they messed up concurrency, basically. Also little cases like sometimes Boeing Dreamliner's AC system stops working because implementation issue. Sometimes Patriot missiles used to miss their targets because implementation issues. And also Chrysler messed up. They did not put a firewall between the internet-connected YouTube player and the car engine because they used a CAN bus, which is not authenticated by default. So formal verification is about formalizing this relationship, and it's recommended to use. There are two kinds of it, basically: system verification and implementation verification. System verification is about your concept, your architecture, your protocol, and implementation is about your code adhering to the protocol, and it's basically an extension of types you are used to. And I'm going to skip that. You can track stuff with your types, and there is also the concept that in really high assurance stuff like space rockets, you realize that your hardware and compiler are also potentially not adherent to the spec, so you check them too. I'm not going to talk about that. Formal verification has been used to great effect in a lot of cases. For instance, Amazon has used it to fix some bugs in their web services and also verify that some optimizations could be made. And its static analysis is used in planes, in the space station, in basically every phone, every smartphone out there, and also in your CPU caches. It's verified that they behave correctly. Also some interesting military applications. What I want to say is things are getting harder, and basically if you don't want the people to die, you have to have really bad assurance process which make iterations slow to a crawl. And if we want to get to the space faster, we have to use formal verification. SpaceX is hiring formal verification engineers right now. Check out these materials, they're cool. Thank you.
Thank you. Next up is small modifications.
I would like to share with you some things that I have found, mostly while walking around cities near the Pacific Ocean. I'm kind of curious how you might relate to these from your perspective. So here is the entrance of a driveway in Seoul, Korea, and there's a small slope on this ramp, and so it looks like someone had cut up tires and fixed it to the concrete with screws so it doesn't slip. And about 50 years ago, a guy called Bernard Rudowski said something like this: "What we need now are not new technologies, but new ways of living." And I guess that's a question that I often wonder when I look at these things made by non-specialists using very primitive materials. Somehow they do something, they change something in our experience of being alive. So here is a photo taken by my friend Chris Berthelsen while he was living in Tokyo, Japan. And someone had added this tire to the entrance of the driveway, which makes a difference. I will just read out another quote by a guy called George Calgunhan. He said that life is improvisation, meaning acting as circumstances permit. At one point, a blade of stone is sufficient as a surgery tool, and stainless steel was not sufficient yet. We live like castaways. So even though here are in two different cities, when the picture on the left is from Mexico City, the one on the right is from Seoul, Korea again, people working in relationship to cars, they make these modifications to offer some kind of protection in the first example. And this was found near the same car park where old posters has been reappropriated for storage. And I feel like this same kind of caring could also be extended to other creatures. So here's a bird feeder found in Tokyo. And often also when we think about boundaries, like fences and borders, it could be a site of separation, but also a site of exchange between people and offering something to your neighbors. And here is a soccer field made on a promenade in Phnom Penh, Cambodia. And the blue tubes are very ubiquitous in that city for water. And here the same tiled ground has been kind of appropriated for anchoring this tent. And this is something that I did with a group of my friends in New Zealand before I came to live in Hamburg last year, where we modified the existing furniture in the middle of the city so it could become more of an open home for strangers to meet. And here we discovered fruits on the edges of a car park. I just read another quote by an anthropologist whose name I have forgotten. He said, "To craft not beautiful and convincing artifacts, but evocative and open-ended materials for further experimentation, to creatively set the scene for a distorted here and now. And if you have any idea what this could be, you are welcome to come and find me in the tea house."
Thank you. Now, a party for quality of life is needed.
Okay, so welcome for this talk. You might suspect that because there's the word party in the title, it's something like an Insta party or crypto party, especially as we are on a hacker conference, but I have to disappoint you, it's about a political party, but I tried to make this a little bit entertaining. So I want to explain my point using references to popular culture, namely the famous series Game of Thrones. Who of you does know this series Game of Thrones? Okay, so I can keep the summary of the plot very short. From my point of view, it's kind of a mixture between a soap opera and a fantasy story, and the soap opera elements are that there are a lot of couples having discussions and making love to each other. Then, of course, there's the Iron Throne, which is the symbol of the power for the whole continent. And then there's this game, who is to occupy this throne. And this game is played, of course, via discussions, including swords and riding knights and even fire-spitting dragons. And from my point of view, the important thing of this series is that this whole game, who will finally occupy this throne, is more or less pointless, because in the north there is the horrible Night King, and he has an army of hundreds of thousands zombie warriors trying to kill all people and extinct all life on Earth. So the whole series is about setting the wrong priorities. And this is the relation to the reality which I see, because the priorities of actual politics are keywords like economic growth, jobs, competitiveness, and in recent time also national identity. But the real challenges, from my point of view, are the collapse of the global ecosystem, which is a crucial condition for the existence of humanity, and also the looming collapse of democracy or even civilization. I just want to give some buzzwords like climate change, biodiversity, multi-drug resistant bacteria, or in the second part, the resilience against autocracy, the ability for rational discourse is declining, and war prevention, if we ever had something like this, is also getting weaker. So one solution approach would be to change the optimization criterion, but there's the problem that the attention for inconvenient truth outside of communities like this one here is nearly zero, and we have prevailing mental infrastructures which favor consume and cheap is cool and everything like this. So changing the optimization criterion isn't easy, but nevertheless our approach is to establish quality of life as a political concept, and therefore we think the intent to found a new party which is centered about this concept might be a way to go. Because currently our society tries to optimize economic growth and the number of jobs, but these can only be the means for reaching quality of life, but not be the goal itself. So quality of life, in our understanding, is just a mass-compatible interpretation of sustainability, or more precisely, establishing a lifestyle which will work on a global scale and on a long-time scale. And obviously, our current lifestyle does not fulfill any of these two conditions. And one very important key aspect is to deconstruct the dogmatic growth orientation. So, if you want to have more information, you can ask me, or just visit our website, which is partyoflifequality.de, so plq.de. Thank you very much.
Thank you. Next up is Borg backup. I will quickly, I have to set this up in the browser. Bad OPSEC, everybody sees my bookmarks. So now, let's go. It should work with the clicker, I tried it.
Okay. Okay, welcome. I want to tell some words about Borg backup. It came into existence because we made a fork of the Attic backup software. And back then, Attic was not very well known, but some people already discovered it and were quite happy with it. There comes this citation. Some Greek guy said, "I found the holy grail of backups." So it looks like he was quite happy with it. And how Borg came to life is Attic was a 5-year-old project. It had a quite nice design and nice code, but the problem was a bit the development was going on rather slowly and still some bugs left. And the problem was you could make a lot of pull requests, but they did not get reviewed and not accepted. So it was basically going slower or even be stalled. And after some months, I think, of waiting, we forked it. And that was 2.5 years ago. And now it's quite fast going, and it's more or less a community project. And pull requests get merged, and it's quite a lot of activity. The feature set, it's easy and fast to use. It's a command line tool. It does content-defined chunking, more about this later. And it does deduplication, and not only based on a whole file, but on chunks of files. It does compression. In January, I think I will release the next version, and it will even include a Z standard. It does encryption. It authenticates the encryption, and it has a file system, key value store, and you can access it locally or by SSH. It's BSD license, documentation is quite nice, good platform support, Linux, BSD, Solaris kind of stuff, Cygwin even. It's Python, a little bit of Python and C to speed up the critical parts, and we have continuous integration system and quite a nice test coverage. You can mount a backup repository, so you can just look inside and copy files with your files manager. Some words about a deduplication, because compression and encryption, you maybe can imagine how that is done. The deduplication is interesting because it does this chunk-based deduplication. And for example, if you have a virtual machine image and you just use rsync with this hard link trick for deduplication, it will often copy the whole virtual machine image to your backup disk because the whole file has changed. But Borg deduplicates the chunks, and so you will notice that most of the chunks of the file did not change, and it will only copy the changed ones. You can also work on logical volume snapshots. You can deduplicate a directory even if it was renamed, because it does not care for the name, it only cares for the pieces of content that you have. You will have maybe some inner deduplication because you have some duplicates in your file system, but that's not the main point. In any case, you will have a historical duplication because every backup you make will be mostly similar to the backup you made the day before. So there's a huge deduplication there. And you can also have deduplication between different machines if they happen to run the same operating system or if you have the same data on them. How is it made? It reads the file and then it applies a rolling hash algorithm over a small window, and it cuts the file into pieces. And the nice thing that the piece cutting is not at fixed offsets. It happens by content. So if the content is moving, the cutting place is also moving. And then it stores the stuff into a key value store, and that's basically it. Currently we have the 1.0 release out since a while, 1.1 I mean, 1.0 is the old one, and yeah, 1.2 are some crypto and parallelization enhancements. This is the homepage. You can also grab me here. Thank you.
True. Thanks. So next up is Unstillbares Verlangen, but I think it's an English talk. It just has a German title.
Hi, I'm here to talk about insatiable desire. Now, this isn't a technical talk, so there won't be any dirty pictures. Sorry, this is the dirtiest that we'll get. I think many of us are actually a little uncomfortable talking about desire, including myself, so it doesn't come up a lot. And what I love about our Congress is talking about the future and creating solutions to our problems using technology. And I would like to contribute to an element that I feel is a little underrepresented in that. So if we look at ourselves, we have this narrator in the front of our head that comes up with very reasonable explanations for our decisions. But our decisions in many cases are influenced by our desires. Not only sexual desire, but other things, food, money, power, love, friendship, so good things. All I'm saying is that our lizard brain is in the driver's seat a lot of the time, and that has implications for our society. So a large part of our society is built around catering to our desires and selling us stuff, and technology is coming up with better ways of serving our desires every day. And you might say, so that sounds pretty good, what could possibly go wrong? Well, if you take any statement, you need food to live, and take that statement to its logical extreme, then it becomes absurd. So if you need food to live, why don't you eat yourself to death? And we are eating ourselves to death because food has become so good that it's addictive. We can't stop eating even if it kills us. And more is usually better. It's just that our lizard brain doesn't know when to stop. And the same is true for other things. So if I have $1 billion, I won't be happy until I have $2 billion. Or take drugs. Ever since legalization of cannabis started, industry has taken over for obvious reasons. And there's been an explosion in the variety and potency of THC products, which sounds good, but we have no idea what that is doing to our brains. And I think it's easy to blame capitalism and consumerism for our problems, but what if we have that the wrong way around? What if they are actually symptoms of human desire, and they are bounded just like we are, because we are engineered that way and society is built around that? Well, the implication is if you take anything to its logical extreme, it becomes absurd, and our world is built around fulfilling human desire, which is impossible because human desire is infinite. So there might be some bad outcomes from that, say climate change. And thinking about the future, depending on who you ask, in the future, everything will be free. We will live in the collaborative commons. Or in the future, we will try to become gods. Or super intelligent machines will take over and murder everybody. But I feel like we're missing something. I think that human desire will actually play a large role in shaping that progress and determining our future. And I see this going one of three ways potentially. So one way is we can just continue as is and enjoy the ride. And it will be fun for us, not so much for our children, but anyways. Or we can find a way to limit or change human desire, which could be good, but could also be very scary. Or we can put our faith in technology to find a way to satisfy human desire without the external consequences. For instance, build a virtual world that's just as limitless as our desire, and then we can live there and be happy without destroying our actual planet in the process. I don't know if those are good solutions. I think that maybe there are some better ideas. What I'm asking you is next time you discuss some technical solutions, think about insatiable desire. Thank you.
Thank you. Next up is DHCP anonymity. profiles and implementations. Are you there? Does anyone want to give this talk?
We've got the slides.
Huh. Yeah. Yeah, I just, okay, he's apparently talking about DHCP servers and lots of computers that are connected to them, and even a printer also.
You really do want to give the talk.
Yeah, well, Windows, okay. Yeah, I'm sorry it didn't work out. Maybe I didn't get an email or anything. He just didn't show up. Yeah, I think that's it. So, the usual suspects, Android, iOS. Yeah, well, that's a tragic end to our session, I would say. Please give a big hand for all the talkers who showed up.